With a population surpassing 230 million and an economy that consistently ranks as the largest on the African continent, Nigeria possesses all the markers of a regional powerhouse. Yet for decades, one of the most fundamental systems required to sustain a nation of this magnitude operated in a state of near collapse. The country's railways were slow, technologically obsolete, and in many stretches entirely non-functional. When a country this vast relies almost exclusively on road networks to keep its economy moving, the consequences are predictable and severe. Highways become choked with traffic. Heavy trucks transport everything from refined fuel to staple foods across thousands of kilometers. Deliveries are delayed, logistics costs skyrocket, and infrastructure designed for a fraction of the actual demand buckles under relentless pressure. This was the exact reality Nigeria faced for years. But over the past decade, a profound transformation has begun to take shape. China entered the picture with a vision that goes far beyond patching up deteriorating tracks. How exactly is Beijing orchestrating the complete reconstruction of Nigeria's railway infrastructure? And more critically, can this ambitious network genuinely resolve a transportation crisis of this magnitude? To grasp why this undertaking matters, we must first examine the system that existed before these new lines were ever laid.
Nigeria's original rail network was never engineered to support a modern, integrated economy. The majority of its infrastructure traces back to the early 20th century, when British colonial administrators constructed railways with a singular extractive purpose. The tracks were laid to funnel raw materials, such as cocoa, groundnuts, tin, and other minerals, from the interior directly to coastal ports for export. The design prioritized outward shipment over domestic connectivity. It was not intended to link major urban centers in a balanced manner, nor was it built to accommodate industrial expansion or high-volume passenger travel. That foundational blueprint dictated how the system operated for generations. Technically, the entire network relied on narrow-gauge tracks, measuring approximately 1,067 millimeters, a standard significantly narrower than the modern international gauge. This physical constraint severely capped both operational speed and cargo capacity. Trains moved slowly, hauled limited volumes, and grew increasingly inefficient as economic and demographic pressures mounted. Following independence, rather than pursuing comprehensive modernization, the railway sector endured decades of chronic underfunding. Maintenance schedules slipped, rolling stock deteriorated, and service reliability plummeted. Gradually, vast sections of the network fell into disuse. By the early 2000s, official records still listed over 3,500 kilometers of rail lines, but on the ground, only a fragmented fraction remained functional. Even where trains continued to run, services were erratic, painfully slow, and wholly inadequate for a rapidly expanding population.
As the railway system deteriorated, road transport quietly absorbed the entire burden. Today, upward of 90% of Nigeria's freight moves by truck. This includes imported cargo disembarking at Lagos terminals, nationwide fuel distribution, construction supplies, and agricultural harvests traveling across regional boundaries. However, highway logistics carry inherent structural disadvantages. Transporting goods by road is substantially more expensive per ton, particularly over extended distances. In Lagos, one of Africa's most congested port cities, the bottleneck became critically acute. Freight trucks routinely endure multi-day waits
To reach terminal gates, the arterial highways feeding into the port operate in a state of perpetual gridlock, slowing supply chains, inflating operational costs, and stifling business competitiveness. This crisis unfolds in a nation of more than 230 million people, where logistical demand compounds annually. The issue was never a shortage of economic activity or demographic scale. Nigeria had the population, the commercial momentum, and the urgent need for high-capacity transit. What it lacked was a railway framework capable of carrying that weight. That precise gap is where China intervened, not to rehabilitate a failing system, but to construct an entirely new one from the ground up.
At this juncture, the necessity was obvious. Nigeria required a modern rail network, But engineering a system of national scale demands more than political will or market demand. It requires massive capital, specialized technical expertise, and long-term strategic planning. These are hurdles that frequently derail infrastructure ambitions, especially when project valuations climb into the billions. This raises a critical question. Why did China step forward, and why choose Nigeria? Over the past 2 decades, Beijing has positioned itself as the world's foremost infrastructure developer, extending its reach across Asia, Africa, and portions of Europe through frameworks like the Belt and Road Initiative. Nigeria aligns seamlessly with this continental strategy. It is Africa's most populous nation, hosts one of the continent's largest economies, and occupies a pivotal geographic position in West Africa, with direct access to Atlantic shipping lanes. From a Chinese strategic standpoint, investing in Nigeria means engaging a market with sustained infrastructure demand and significant regional influence. For Nigeria, the calculus was different. The country needed a development partner capable of financing and executing mega-projects at an accelerated pace. Conventional funding avenues, such as multilateral development banks or Western-backed assistance programs, typically involve protracted approval processes, stringent conditionalities, and funding caps ill-suited for projects of this magnitude. China introduced an alternative framework. Financing typically flows through state-owned institutions, like the Export-Import Bank of China, which extends loans explicitly earmarked for infrastructure development. These financial instruments are frequently structured to align with Chinese engineering and construction firms, creating a vertically integrated ecosystem that manages both capital deployment and physical execution. This synergy is transformative. It eliminates the lag between financial approval and groundbreaking. It enables projects to advance as unified packages rather than disjointed phases, and it mobilizes contractors with proven track records in delivering large-scale rail networks. Central to many of these initiatives is the China Civil Engineering Construction Corporation, an enterprise with decades of operational history across Africa and a dominant role in delivering Nigeria's new rail corridors.
To appreciate the scale of this endeavor, one must understand the technical foundation. The most fundamental shift begins with the rails themselves. The emerging network is being constructed using standard gauge tracks measuring 1,435 millimeters. This is the internationally recognized benchmark adopted by modern high-capacity railway systems worldwide. This single engineering adjustment enables trains to travel faster, haul heavier payloads, and maintain operational efficiency across long-haul routes. But track width is merely the starting point. The broader objective is to interconnect Nigeria's primary economic zones through a deliberately structured grid. This involves bridging coastal gateways with inland metropolitan areas, linking industrial clusters, and establishing dependable transit corridors for both commercial freight and passenger mobility. Nationally, the architecture revolves around several strategic arteries. Lagos, the country's commercial nucleus and busiest port, anchors the southern terminus. From there, routes extend inland toward Ibadan, continue northward to Abuja, the federal capital, and ultimately push toward Kano, one of the largest trading hubs in the northern region. Additional planned junctions will weave more cities and provinces into the grid, forming a system capable of moving goods and travelers across vast distances without forcing them onto saturated highways. In scope, this is a multi-phase initiative spanning thousands of kilometers. Each segment is engineered as part of a cohesive network rather than as a standalone project. This distinction is vital. Rail systems only unlock their full potential when they function as interconnected corridors. A single line can optimize travel between 2 points, but an integrated network can fundamentally reshape national mobility. That is precisely the tier Nigeria is targeting. When viewed holistically, this initiative transcends incremental upgrades. It represents a complete systemic replacement. Nigeria is transitioning from a fragmented, underperforming legacy network to a standardized, high-capacity framework engineered to sustain long-term economic expansion.
Yet a blueprint of this magnitude holds value only if it materializes on the ground. The most effective way to evaluate progress is to examine the first major operational corridor, the Lagos-Ibadan line. This route provides a tangible window into Nigeria's rail future, not as a theoretical projection, but as a functioning reality. The railway stretches approximately 157 kilometers, linking Lagos, the nation's economic engine, to Ibadan, one of the largest urban centers in the southwest. While the distance may appear modest, this corridor facilitates some of the highest volumes of passenger and freight movement in the country. Prior to its construction, this traffic relied almost entirely on roadways that were perpetually overstressed. The new railway fundamentally alters that dynamic. Construction commenced in 2017, and the line officially entered commercial service in 2021. Financially, the project is valued at roughly $1.5 billion, predominantly funded through Chinese lending mechanisms, with the Nigerian government contributing counterpart financing. Execution was managed by the China Civil Engineering Construction Corporation, which oversaw both engineering design and physical construction. Passenger services on this route can achieve operating speeds of up to 150 kilometers per hour under standard conditions. But velocity is only one dimension of the upgrade. The corridor features contemporary terminal facilities, including the Mobolaji Johnson Station in Lagos, engineered to process high passenger volumes with structural efficiency. Boarding procedures are streamlined, ticketing is fully digitalized, and service reliability has markedly improved. For freight logistics, the implications are even more consequential. The Lagos-Ibadan line interfaces directly with the Lagos port complex via dedicated branch tracks, enabling shipping containers to transition inland by rail rather than depending exclusively on truck convoys. This shift is critical, given that Lagos processes a substantial proportion of Nigeria's imports. Accelerating cargo evacuation from the port alleviates pressure not only within terminal boundaries, but across the entire surrounding road network. This is precisely the bottleneck the new infrastructure begins to resolve.
However, a single operational corridor cannot single-handedly resolve a national transportation deficit. It remains one segment within a far broader framework. To understand how this network expands beyond an isolated route, attention must shift to another line completed earlier, which serves a distinctly different operational role: the Abuja-Kaduna Railway. This corridor provided the first concrete indication that Nigeria was transitioning toward a modern rail paradigm, predating the Lagos-Ibadan commissioning. It stands as the country's inaugural standard gauge line and established the operational template for subsequent projects. The route spans approximately 186 kilometers, connecting Abuja, the federal capital, to Kaduna, a major urban and industrial node in the north. Groundbreaking occurred around 2011, and the line officially opened in 2016. The project carried a valuation of roughly $874 million, with the overwhelming majority of financing sourced from Chinese concessional lending. Consistent with other initiatives, construction was executed by the China Civil Engineering Construction Corporation. From an engineering standpoint, the line introduced standard gauge infrastructure at a meaningful operational scale. Trains on this corridor travel at speeds reaching 120 kilometers per hour, delivering a level of schedule consistency and reliability that was largely absent in the legacy system. Yet what truly distinguishes this route extends beyond its technical specifications. It lies in how it is utilized. The Abuja-Kaduna Railway rapidly emerged as one of the nation's most heavily trafficked passenger lines. Demand remains persistently strong, with services frequently operating at or near maximum capacity. The line also accommodates freight traffic, though passenger mobility continues to dominate its current usage profile. Like the Lagos-Ibadan corridor, this remains a single component of a significantly larger vision.
Alone, it bridges two major cities. What Nigeria is actively constructing is substantially more ambitious. A continuous rail artery spanning from the Atlantic coast deep into the northern interior. This brings us to the next developmental phase, the Lagos-Kano Mega Corridor. This route functions as the structural backbone of the entire network. The concept is straightforward. Begin at Lagos, the primary port and commercial center. Advance inland to Ibadan. Continue northward to Abuja. Extend further to Kano, a historic trading powerhouse in the northern region. When fully interconnected, this corridor will exceed 1,340 kilometers in length. Development is proceeding in sequential phases. The Lagos-Ibadan segment is already operational. The Abuja-Kaduna line, completed earlier, forms a critical central anchor.
The remaining junction between Kaduna and Kano remains under active construction, with ongoing efforts focused on closing the final geographic gap. Once these segments achieve full continuity, Nigeria will possess an unbroken standard-gauge railway linking its most active maritime gateway to one of its most vital inland commercial hubs. This transformation will fundamentally redefine domestic freight logistics. Yet the implications extend well beyond cargo movement. Passenger mobility will gain unprecedented efficiency. At a macroeconomic level, the network begins stitching together historically disjointed regional economies. The southern coastal trade zone gains direct rail access to northern consumer markets. Agricultural produce can flow more efficiently toward urban processing centers. Manufactured goods can access broader distribution networks. In essence, the corridor aligns.
Supply chains with demand centers across vast geographic distances. That is where the true economic utility of a national railway network resides. It is not merely about transporting passengers or freight between two points. It is about integrating fragmented territories into a single, cohesive economic ecosystem. So, how should this transformation be interpreted? Is China actively helping Nigeria lay the groundwork for sustained structural economic growth? Or is this financing model accumulating debt burdens that could constrain future fiscal flexibility? Modern infrastructure undeniably serves as a catalyst for development, but questions surrounding repayment structures, long-term operational sustainability, and genuine economic returns remain critically important. Share your perspective in the comments below. Weigh in on the strategic implications, and subscribe for ongoing analysis of the infrastructure shifts reshaping Africa's economic landscape.